Hi, this lesson is all about the volcanoes that we find on Mars. As preparation for this, just to remind you some features about Martian volcanoes from what we studied before and what you did in the last lesson, make sure you've watched the first video that's listed on the lesson guidance notes. Okay, the surface of Mars has been mapped quite thoroughly. This image is, if you like, a flattened version of a map of the whole of Mars. You've got a copy of this, a black and white one, on page 14 of your Theme 2 booklet. And it's page 14 that we're working on today. Okay. We need to think about some of the volcanoes that we find on Mars. We've already looked at one of these volcanoes in some detail when we did Theme 0. The biggest volcano that we know of in the solar system, called Olympus Mons. If we think for a moment about how we know that this is a volcano, how can we recognize this extinct feature on the surface of Mars as a volcano? It's really down to the features that we see on it. We can see that there are a lot of similarities between a volcano on Earth and Olympus Mons. Now, admittedly, there are some big differences, principally size. But that same shape, in this case a shield shape of a volcano, we see the surface craters forming these features we call calderas. And we can see evidence running down the side of some really quite extensive lava flows. Now, Olympus Mons is the biggest of these features, but it's not the only one. This is an extract of quite a detailed scan of the Martian surface. The different colours here represent different heights. We can see that Olympus Mons, which is the feature in the top left of this image, has similar patterns replicated in other places. We can actually start to recognize other features from their conical shapes, from these summit calderas, the summit craters, and some of the other lava flow features that we can find to actually identify where volcanoes are on Mars. Okay, so what I'd like you to do is, in a moment, press pause on the video to give yourself some time to work through the activities on page 14 of your Theme 2 booklet. I'd like you to try and identify any of the volcanoes you can find on the Martian surface. Look for these distinctive conical features. Highlight them on your version of the surface map of Mars. I'd then like you to think about the other questions B and C, okay? The similarities and differences between these volcanoes and what that's telling us about Martian geology. Think back to some of the other videos that you've watched in this lesson and the previous one. Okay, so press pause now and have a go at those questions. Okay, if you've had a go at those questions, let's have a look at what this tells us. This is the surface view of Mars that you have in your books. You can see there are some fairly distinctive features. Let me highlight the volcanoes on this map. The first one is Olympus Mons. Okay, these are the volcanoes that we can identify. You'll notice there's something perhaps unusual. There's a very limited number of these, although we do seem to see clusters and even perhaps some lines of these volcanoes that may indicate perhaps key sources of magma. But the fact that these volcanoes, should I say, are recognizable, even when we're looking at a map of the whole planet like this, shows us something about the size of these volcanoes. Clearly, they're much bigger than any we find here on Earth. Not only that, the numbers of them are also very different. Let me show you a comparison of Earth. If we compare this with a map of Earth, we'll see that it's a very, very different picture. The most obvious difference, looking at this, is just the sheer number of volcanoes. On Earth, we have maybe 600 active volcanoes at present. This particular map shows us the active ones and also the ones that have been active in the fairly recent geological past. Not only that, if I showed you a map of the Earth at the same scale as the map of Mars that you've been working on, you wouldn't be able to identify really any of these volcanoes. Possibly the big island of Hawaii. But other than that, I think we'd struggle. So clearly the volcanoes on Earth are smaller and more numerous, as well as more active, than any on Mars. Now the reason for this is plate tectonics. Plate tectonics are active crust. The fact that what we see on the Earth's surface at the moment is in constant motion makes for, well, more volcanic activity as these plates meet. But also it means that any one volcano is going to have perhaps a limited lifespan. That volcano could be moved away from its source of magma. New sources of magma created by new plate movements will create new volcanoes. So Mars gives us an indication of a very different tectonic setting. We think there was tectonic activity on Mars. We have some evidence for that, but perhaps of a very limited nature. Perhaps those volcanoes stayed in one particular place above one source of magma for a very, very long time. Okay. If we looked at a map of the Earth at the same scale as the map of Mars I've given you, I think you'd struggle to find any volcanoes. The only possible exception might be the big island of Hawaii. Okay, one of the extension videos looks at a theory about a supervolcano on Mars. Perhaps one that's less obvious than the ones we've found, in a place called the Arabia Terra. If you're interested, well, I've labelled up the location of the Arabia Terra on your map. If you're interested, click on one of the extension videos listed on the lesson guidance. So, the volcanoes of Mars perhaps give us a prediction of Earth's future. If we see a planet like Mars that loses its heat, where plate tectonic activity stops, where the volcanoes stay in one place for any long period of time, that might show us what Earth could look like when our heat has dissipated. Relax though, we think it might take about another 1,000 million years for this to happen. But it's an interesting theory. Next time, we're going to be looking at comparing some of the geological features on Earth with those on Mars.